All right, so remember last class we were working with the law of sines, which basically was this business, that was pretty cool, right? And basically for all these problems, you're given three values and you need to find the other three. So here you're given a triangle A, B, C, and it doesn't really matter what's A, what's B, and what's C as long as the sides correlate with the angles. Okay? So here you have A is 40, B is 30. So then C, you can just do 180 minus 40 minus 30, which would be 110. So that you already have right off the bat, angle C is 110 degrees. And side B is 10. So what you're going to do now is use what you're given to solve for what you don't know. So essentially all you're doing is setting up like a proportion. So like you'd say 10 and sine 30 would go together. So you'd have sine 30 over 10 equals, and then you just solve for one of the missing sides. So you could either solve for side C or side A. So we can start with side C. So I'm just going to say sine 110 over C, and then you would just carry out the math. So you'd cross multiply, so you get C sine 30 equals 10 sine 110, and then divide by sine 30. And then for this part, you would just do it on your calculator. So make sure you're in degree mode. So mode, make sure you're in degree. And then just go ahead and type it in. So 10 sine 110 divided by sine 30. And you'd get 18.8. So C equals 18.8. So we've solved for angle C, we've solved for side C, and then you would just do the same process to solve for side A. So you'd say sine 30 over 10 equals sine 40 over A. And then again, you would cross multiply and solve. So you'd get A equals 10 sine 40 over sine 30. And you get 12.9. And that's really all we did last class. All right, so today we're going to go over some notes. All right, and it's about that ambiguous case, which is S at side angle, or really angle side, because that's what it is. All right, I tell you that because that's an easy way to remember it. All right, if you have angle side, what's going to happen is there could be a potential for two possible triangles. All right, there could be 0 triangles, there could be 1 triangle, and there could be 2 triangles. That's why it's the ambiguous case. All right, because what you could end up with is a triangle like this, right, where the sides can't connect. But you could also end up with 2 triangles or just 1 triangle. So just real quick, we'll run through this. The sum of the angles in a triangle is what? 180. No triangle can have two what? Right angles, or what else? Obtuse angles, right? So angles 90 or above. The sine function has a range of y values between where? Think of the graph, y values. So -1 is less than y is less than 1. I guess it's less than or equal to. All right. If sine is greater than 0, then what two quadrants could we be in? Yeah, right, 1 and 2. So it could be in the first quadrant. If it's in the first quadrant, what angle would that be, acute or obtuse? Acute, right? Acute angle. Or in the second quadrant, what would it be? Obtuse. So this is where you'll see we have two angles. And the smallest angle in a triangle is opposite the... Not necessarily. Just the smallest side. Okay? So that's just some background knowledge to help you with these problems. All right. So given triangle ABC with angle A is 30, A is 7, C is 16, how many distinct triangles can be drawn? Solve if any. So the first thing I do is always draw a picture. Okay? And I draw all my pictures the same, really, at first, regardless of what the angles are. If that bothers you, you can do yours more accurately. So I do A, B, and C, A, B, C. And this is typically how I set mine up, just so I'm consistent. So angle A is 30 degrees. Side A is 7. And side C is 16. So you see here, this is why it's an angle side-side, or side-side angle. All right? Because the angle is not in between the two sides. That would be side angle side. Right? It's the angle and then the two sides. All right, so right away you know you're going to have a problem because it's angle side side. All right, so we would just go through the normal steps with law of sine. So I can have sine of 30 over 7 equals sine of C over 16. Right? That's the same as what we were doing before. And that's to solve for angle C. So you'd say 16 sine 30 equals 7 sine C divided by 7. And do you remember what we had to do next? Inverse sine, right. Use your calculator for inverse sine. So you'd go ahead and you'd say, like I said, I normally do this part first and then do the inverse sine of second answer just so it's less room for error. So 16 sine 30, enter, over 7. You get 1.14. What did we say the range was for sine? -1 to 1. So is this in that range? No, so look what's going to happen when I do second inverse. So the inverse of my second answer, you're going to get this error. Right, so there is no triangle. Okay, you cannot, so this ended up being, what was it? 1.14. So 1.14 equals sine C. So when you take the inverse, sine to the -1 of 1.14, that cannot work because that's not between -1 and 1. So the answer to this one would be no triangles. All right, so if you get that error when you're solving for that first angle, or any angle, the answer is going to be no triangle. All right, so here, same deal. Is this the same exact problem? Okay. All right, so again, start with a picture. A, B, C, A, B, C. 30 degrees for angle A, 10, and 16. All right, and again, you can do the same process. We're going to try and solve for angle C. So sine 30 over 10 equals sine C over 16. So you cross multiply, divide by 10, you get 16 sine 30 over 10 equals sine C. What is the sine of 30? 1/2. So 16 times 1/2 over 10. So that's really 8 over 10 equals sine C. So then you do the inverse sine of 8/10, 4/5. And you get 53.1, we'll call it. All right? So angle C is 53.1. Yeah. All right, so what would that make angle B? .9? Okay. So now you could solve for side B, correct? So you do, again, this gets kind of repetitive. Sine 30 over 10 equals sine of 96.9 over B. So you cross multiply, divide, you end up with B equals 10 sine 96.9 over sine 30. Yes, ma'am. All right, so you get this. Go to your calculator again. 10 sine 96.9 over sine 30. No, because now we're solving for a side. You only do the inverse when you're solving for an angle. So you get B equals 19.9. All right, so I've solved for all three parts. 1, 2. What am I missing? No, I didn't write angle B anywhere. 96.9. Okay? So that's one triangle. Now we have to look and see, okay, inverse sine of 8/10. That could be here, which was 53.1, right? But where else could it be? And still be a positive 8/10. Right, in the second quadrant, here, where this is 53.1. Okay? You see that? So there's so that means we could potentially have two triangles. Because sine is positive in both the first and second quadrant. So anytime you have this angle side side, you have to look at this. All right, so the way you find that second angle is take the angle that you solved for 53.1 and you just do 180 minus 53.1 and that gives you 126.9. Thank you. And now that's your new angle C. Yeah, exactly. Right. So this is your second angle C. All right. So now you have a second angle C, so you have to solve for angle B and side B again. All right. So this is why I was saying it's 30 still A. Yeah. So 30 still A. Now all that's changing is now my triangle, rather than looking like it did up there, it's going to look like that, even though that's not really a triangle. Yeah. Yeah. Okay? It's going to look like this, where this is A, B, C. You don't have to draw like a triangle? No. But I'm just doing this to show you. So this is still 30. This is now 126.9. So what would angle B be? 30, 156.9, 23.1. Yeah, I was waiting for him. 23.1. Okay. So again, you would just solve, what was side A? 10? 10 and 16? So you do sine 30 over 10 equals sine 23.1 over side B. And then you solve doing it the same way. So you get 10 sine 23.1 over sine 30. Ten sine 23.1 over sine 30. And you get 7.8. So we ended up with two different possible triangles. One that looked like this with an obtuse angle, and one that looked like this with an acute angle. So that is the two cases when you have an angle side-side. All right, so the first triangle, you get A, B, C. Okay, so it's angle side-side, right? So you go through, you work it out. For angle C, what did you get? What did you guys get for angle C? 23.6? Okay? So that's here. So then you can solve for angle B, and you got what? 126.4. And once you have this, now you can solve for side B, and you get 32.2. Good. Okay. So this is the first triangle. All right, I didn't go through the work just because I already went through it twice, but you should be good at least getting this first triangle, okay? But now you know it's angle side-side, so you have to look for the possible second triangle. So what you do is take that angle that you solved for using inverse sine, okay? That's important. Take the angle you solved for using inverse sine and do 180 minus 23.6. And you get what? 6.4, okay? So now you have a second case. So this is your second case. So now you have a completely different triangle. So you have this. So this is 30 degrees. This is 156. So what I need to solve for this my third angle. This is 30 degrees, right? So I need to solve for this, so I add them up. I get 186.4. Is that possible? No, so this can't be, because it would have to be -6. So what that tells you is there's only one triangle, and these are the answers. Okay? Go ahead.